helpful. But it only comes up in the context of polynomials that have exactly 4 terms. So let me show you what factor by grouping looks like. Let's do this one. So we're going to do, I forgot the numbers already, 8ab. 8ab minus 16. Sorry, I wrote it down and I forgot what it was. A plus 3b minus 6. Is that what I want? Yeah. Okay, cool. All right, I think that works. So the idea here is I've got 4 terms, and I'll show you a very specific thing that happens when I do greatest common factor twice. It's going to end up being greatest common factor 3 times in order to factor this. So the goal when I'm factoring is I'm trying to get a polynomial times another polynomial, because as you learn more about polynomials, you'll find that having the pieces multiplied is actually much more convenient than having them added. Unfortunately, we're not going to get into that too much in this class because it involves kind of more in-depth stuff. But if you go a little bit further, like even if you take the next class, just college algebra, you'll really want to have that happen. You'll want to have your polynomials all factored out so that everything's multiplied instead of added together. It turns out it's a lot more helpful. So here's what we're going to do. I'm going to notice that I've got 2 sets of 2 here, 2 sets of 2 terms, each of which has something I can factor out of it. I can factor a greatest common factor out of each one of those things. And doing so, when I do so, watch what happens. So when I'm taking the greatest common factor out of 8ab minus 16a, I can take an 8a out of each one. So I'm going to. So I'm going to write that as 8a times b minus 2. And then I can take a 3 out of 3b plus 6. So be careful when you're doing this. I'm going to have the sign here, plus, and then I'm going to pull out a 3 from each of those. So it'll be 3 times b minus 2. And lo and behold, these 2 terms are the same. When this happens, you can then factor them out, of course, just like we did in the factor by factoring GCF. And I want to, right? So I'm going to pull out my b minus 2s and be left with b minus 2 times 8a plus 3. And now my original second degree polynomial, notice has degree 2 here because I've got 2 1s on the a and the b, so this term is degree 2, is 2 degree 1 polynomials that are multiplied by each other. This turns out to be this turns out to be exactly what you're looking for. And so that's the basic idea of factor by grouping, is it lets you factor something that has 4 terms in it when you wouldn't normally be able to. Like we'll do some stuff with trinomials next topic. And it's not obvious how to factor this just by looking at it. So what you kind of have to do is when you see 4 terms, you just sort of blindly try grouping and hope it works. Now, with grouping, there's a thing I want to point out here, which is there are 2 ways I can group up these terms that work and 1 way that doesn't. And there's actually only 3 ways to group these terms. So the way you want to think about grouping is this first term here, I could group it with this term, or I could rearrange the polynomial and take this and group it with that term, or I could rearrange it and group it with this 4th term. That's 3 different ways. Oh, and by the way, that's all the groups, because as soon as you group 2 of them, it leaves 2 that go in the other group. So once I've chosen like this first term and this 3rd term to group, then this and this are the other group automatically. So there's only the 3 choices that you've got for ways to group the terms. And in a grouping problem where grouping is possible, 2 of them will work and 1 of them won't. So let's see the other one that works. So if I had rearranged this polynomial to be like this, 8ab plus 3b minus 16a minus 6, right? So all I did was just rearrange the order of the terms. I haven't actually changed anything about the polynomial. I just made it look different. So I'm gonna group these up the same way, right? I'm gonna do, those are my groups. Now, this is gonna, when this particular sign right here is a minus, you have to be really careful. It's very easy to mess this up. So I'll show you the right way to do it. So I'm going to pull out the greatest common factor from each one. The first set of first pair of terms there has just a b in common. So that's what I'm going to pull out. It'll leave me at 8a plus 3. And now here, I'm going to do this in this way. I always make this middle term a plus, and then decide what I want to pull out of these two. So I'm thinking of this as like plus a negative 16a minus 6. Now, here's the thing. I want to get 8a plus 3, right? I want to get whatever's in here to be the same in both. To make that happen, I need to pull out a negative 2. I could pull out 2, right? If I just pull a 2 out of this, I'll have minus 8a minus 3, which is almost what I want. It's got an 8a and a 3, but the signs are wrong, right? So if you think back to when I was talking about greatest common factor in the previous topic, sometimes you want to make this thing inside into something specific. In this case, I specifically want it to be 8a plus 3, not minus 8a minus 3. So instead of pulling out a plus 2, I'm going to pull out a minus 2 out of both. So this is going to be plus a negative 2 times 8a plus 3, right? And plus or minus, of course, is just minus. So let me go to the next board and see what we've got. So I've got b times 8a plus 3 minus 2 times 8a plus 3. And lo and behold, same thing in the parentheses. Great, we're going to pull that out. We're going to 8a plus 3 times b minus 2. Okay, and now note, the thing you want to notice here is that this factored form is the same as this one. It's in a different order, but that's irrelevant, right? It's multiplying, this is multiplication. You can do it in either order, in the same way you can do 3 times 5 or 5 times 3 and get the same thing. If you do b minus 2 times 8a plus 3, you're going to get exactly the same thing as 8a plus 3 times b minus 2. So either order is okay. And so that one, that works fine, right? Everything worked okay. So now let's see what happens if I rearrange it to be, if I group the 8ab with the 6. So I'll have 8ab minus 6 minus 16a plus 3b. So 8ab minus 6 minus 6 plus 16a minus 3b minus 16a plus 3b minus 16a plus 3b. And that is another valid way to arrange your polynomial, to group them up. So so now my groups are this and this. I'll pull a 2 out of the first group, 2 times 4ab minus 3. And I will look at the second group and say 16 doesn't have anything in common with 3. A doesn't have anything in common with B. There's actually nothing I can pull out there, which means that I should pull a 1 out. So that's what I'm going to do. I'm going to do plus a 1 times minus 16a plus 3b. And those things inside aren't the same, right? So this and this are not the same. And so I can't factor those two out front because they're not alike. You can only do that if they're the same thing and you're just undistributing, but that's not the case here. So this didn't work. Now you might say, well, hang on. All we did was order the polynomial differently. How come it doesn't factor now? And it does factor. It's just that you can't see it in this grouping, right? This is the one grouping that doesn't work. So this is what I meant by there are 3 different groupings, 2 of which work and 1 of which doesn't. And the 2 that work correspond to the 2 different orders that you can put the polynomial in, right? This one was b minus 2 times 8a plus 3. The other one was 8a plus 3 times b minus 2, right? 8a plus 3 times b minus 2. And so those 2 different orders go with 2 different groupings, but this is not one that works. So sometimes when you are trying grouping and the first grouping you try doesn't work, try rearranging it and see if that works, because it could just be that you got the bad one first. And so if you just rearrange it to anything else, it should work. Like if it is possible to factor the polynomial by grouping, and you just happen to get the bad one first, then any other arrangement is one of the good ones. And the grouping should work fine. So yeah, there you go. That's the basic idea of factor by grouping. Let me show you a couple more examples, and then we'll call it good on grouping. Another example here. So I'll steal this one out of the book. So we'll go x cubed 3x squared minus 3x minus 9 plus 3x squared minus 3x minus 9. All right, so this is another excellent example. So I do want to point this out. You want to be real careful of this middle sign. When that's negative, it's very easy to mess up, because when you pull something out, that negative gets distributed in. So you have to watch out for that. Just be really careful with that negative. That particular negative is the problem one. So I'm going to group these up. And again, there are 3 different groupings I can choose. I can choose to group this x cubed with a 3x squared, or with a 3x, or with 9. The only one that doesn't work is the 9. So when you have this nice descending order on your polynomial and it's got 4 terms, the first 2, like grouping x cubed with 3x squared or grouping x cubed with 3x, both of those will work. And then the one that won't is the third one. So that's another reason to put your polynomials in descending order. If you're going to do grouping, the working ones are the first 2. Okay, so I'm just gonna leave it as is and group like this and this. And so I will pull an x squared out of the first group, x squared, and that'll leave me x plus 3. And then I'm going to put a plus sign, and that'll leave me 3x or minus 3x minus 9 inside. So let me just make this point again. Minus 3x minus 9. That's my second group. I would like this to turn into x plus 3 when I factor something out. Well, these signs are all negative, so I'm going to pull out a negative 3 rather than a positive 3, because that'll leave me with plus signs inside, which is what I'm going for. So minus 3 times, well, when I pull a minus 3 out of minus 3x, I'm left with x, and then plus 3. All right, let's rewrite that. X squared times x plus 3. Not plus, that is minus 3 times x plus 3. And then I can pull the x plus 3 out, the common term between the two. That leaves me with x squared minus 3. There we go. Fantastic. That works nicely. Now, sometimes what you're going to want to do is to pull the GCF out first. Sometimes, always pull your greatest common factor out. If there's a factor that is common to all the terms, always pull it out. It will always make the factoring easier. Always, pretty much always. I'm trying to think if there's a weird case where it might not, but no. I'll just say always pull the GCF out. It's going to be your best move in general. So let's see a nice messy one here. P to what power? 2. Okay. P squared Q squared Q squared. I'm just stealing these examples from the book. If you want to see the example worked out on paper, it's in the book. I'm on page 364 right now. P squared Q plus 60PQ squared minus 45PQ. Okay. So you might notice that these terms all are multiples of 3. I think that's the only one. They also have some amount of PQs in them, right? They all have at least 1 P and at least 1 Q. So I want to pull out 3 PQ. Is it just 3? 3. Yeah, it's just 3. Okay. I want to pull out 3 PQ out of everything, and then that'll make my job a lot easier. So here's what happens whenever you factor a greatest common factor out of a polynomial and then do more stuff to it. When we factor the greatest common factor out, it's just going to sit out front and not do anything the rest of the time. So I'm going to pull 3PQ out, 3PQ. And that's going to leave me inside 8PQ minus 6P, right, because the Q is already out there, plus 20Q minus 15, no letters. Let's just make a quick check. That'd be 24P squared Q squared minus 18P squared Q plus 60PQ squared minus 45 PQ. Okay, yeah, that looks good. So what I was doing there was just checking to make sure that I had done the greatest common factor correctly. It was a little bit messy, and I want to make sure I'm doing it right, so I don't mess the video up. You should definitely do that on when you are doing these, especially if you want to be absolutely sure that you're right. Check every step and make sure that you're doing it correctly as you go along. All right, so now what I'm going to do, I am going to group these guys like that. Yeah, and notice what happens with the 3PQ. Nothing. Nothing's going to happen with it. It's just going to sit there and do nothing the whole time. Goes in every step, but it doesn't actually do anything. So I'm gonna pull out a 2p. It looks like 2p, leaving me 4q minus 3. And then I'm going to pull a 5 out. Oh, and I do want to point one thing out. This sign right here is plus, which is good. Everything's easier. No need to worry about distributing the minus sign. So I'll pull a 5 out. And that will leave me 4q minus 3. Hey, look at that. Those two things are the same, just like we wanted them to be. And so I will pull out 4q minus 3. So next step, still 3pq times 4q minus 3. I've got an extra set of parentheses there. Times 2p plus 5. And I don't need all these parentheses, just one set will be fine. So this is 3pq times 4q minus 3 times 2p plus 5. Sorry about the phone there. Okay. There you go. That's it. Hang on a second. We're going to pause that. Sorry about that. I'm staying with a friend. They've got they had a phone call. They got a phone call about a doctor's appointment. So let me go back to here. There we go. So here's where we're at. I want to pull out the greatest common factor. And again, I cannot emphasize enough. You pull out the greatest common factor and then don't do anything with it. It just sits there, right? It sits there up front while you factor whatever's left inside. This is a very common thing. We'll see this significantly more often, especially in the next two topics. So that is factor by grouping. The basic idea is you have 4 terms and you group them up into 2 pairs of 2 and then do greatest common factor 3 times, right? Greatest common factor on the first set, greatest common factor on the second set. And if you've arranged it right and grouping works, and by the way, sometimes it doesn't, but if you've arranged right and grouping works, then greatest common factor, then you'll have a common binomial factor that you can then pull out. So let's see one where it doesn't work. So let's do factor by, let's try to do factor by grouping here. So I'll do like x cubed plus 5x minus 2x plus 11. All right, so, oh, excuse me, this is supposed to be 5x squared, my bad. So I got a pretty obvious pair of groups like this, right? And so I will pull x squared out of the first one times x plus 5. And then I don't have any common factors between 2x and 11, but that's okay. I can pull out, since I've got minus 2x, I'm going to pull out a -1. So minus 1 times 2x minus 11. Let's rewrite that. So we get x squared times x plus 5 minus 1 times 2x minus 11. And these guys are just different. I could try rearranging it, but I know that since I've got my 4-degree polynomial or my 3rd-degree polynomial arranged in descending order, the only two that'll work are x cubed plus 5x squared or x cubed minus 2x. And if I did rearrange it, that one wouldn't work either. Nothing works here. Sometimes you can't factor a 4-term polynomial by grouping. In fact, most of the time you can't. You have to have this particular arrangement, or you have to have a particular arrangement of terms like this. So let me point out to you when you can and when you can't. So this one worked. And the reason it worked is that the ratio of the coefficients is the same. So the ratio of 8 to 6 is, or 8 to negative 6 is the same as 20 to negative 5. This is, if I reduce this, this is like 4 to negative 3 and 4 to negative 3. And all the ones that worked, you're going to see that that's true, right? This is 1 to 3. This is negative 3 to negative 9, which is the same as 1 to 3, right? If I do 3 over 1, I'll get the same thing as if I do negative 9 over negative 3. And for grouping to work, that has to be true, right? So all of these work here too. 8 to negative 6, 4 to negative 3, negative 16 to 3, or excuse me, that one doesn't work. So the reason that doesn't work is that we rearranged it so that ratio didn't hold properly. So over here, this is one that work, right? 8 to 3, and then negative 16 to negative 6. It's also 8 to 3. Same thing up here. So if you get that ratio of your coefficients, the same ratio of coefficients in each of the pairs or in each of the groups, then grouping can work. If you don't, it can't, right? And there's no way to make that work here. I've got 1 to 5 and negative 2 to 11. Those are not the same, doesn't work. If I rearrange it to be x cubed with the 2x, I'd have 1 to negative 2 and 5 to 11. Those are not the same either. That doesn't work again. And same thing if I did the x cubed and the 11. So the only way factoring works is if the ratio of coefficients in your terms is the same. And even then, it doesn't necessarily have to work, although it usually will in that case. And I believe that is the only thing I really wanted to say about grouping is how to do that. So yeah, I'm going to go ahead and stop the video here, and I will see you guys in the next one.